All right, we're going to do the middle section of 6.2 today, and I am exhausted right now, so no funny business. We're going to get right down to the task at hand, and yesterday we talked about how to combine if we are adding on a constant, multiplying a constant, dividing, and so forth. And remember, if you multiply, the rule is just multiply. You get to multiply the standard deviation, you get to multiply the mean, all that kind of good stuff if you multiply or divide. However, if you add or subtract, you only add on the mean, the median, the quartiles, the percentiles. Okay, you do not change the measures of spread. Okay, right? Remember that? It just moves the whole thing up, and then it doesn't make it wider or anything. So, centers of spread, or the spread does not change. Okay, so today what we're going to be doing is we're not just adding on a constant. What if we have a couple things that both can wiggle a little bit, right? So basically, think of it like this way. We're not just like saying x plus 6. We're going to do like x plus y. You see, y could also change and x could change, right? Does that make sense? And so we're going to be combining a lot of that kind of stuff. So first off, to be able to do this, you got to make sure they're independent. Now remember, independence basically means one does not affect the other. And in statistics, sometimes we don't mention it's independent or not. But like, for instance, flipping a coin, you should realize that the first flip should not affect the second flip, right? So those would be independent events. Rolling dice, the first roll will not affect the chances of the second roll changing, right? It's not going to change it, okay? So those would be independent. So everything, it needs to be independent, or they'll state it's independent, okay? Otherwise, you cannot combine two variables, okay? All right, that's pretty much what this slide says. Moving on. All right, so how many total passengers can Pete and Aaron expect on a randomly selected day? All right, now Aaron, I don't know if you caught this or not, but they just kind of threw it in. Aaron has not been mentioned yet, and she's kind of trying to slip into Pete's business, and she's also a tour guide as well. All right, so Pete's getting a little chapped. All right, all right. So Pete, as was stated yesterday, expects about 3.75. Erin expects about this many people on her rides, so she's not getting quite as good a business as Pete. But she's new. So, by the way, we did go get water. Yep, Woodman's. So I got water again. So what would be the mean of their total? How many people do they in total give tours? All right. Well, what do you guys think? If you just if it asks you to add them together, guess what you're going to do to the means? You are going to add them together. So the mean of the total, and I'll say mean of their, I'm going to call it total for T, will be, and I would add those two together, and if I add them together, that's what, 6.85. Okay? That's pretty easy. Notice, so far, what happens if we multiply to, a number to a mean? You just multiply that number to it. What happens if you add a number to a mean? You just add. What happens when you want to add two means together? You're just going to add, right? Means are the easy ones, right? They're always going to do what you expect. However, ladies and gentlemen, let's move on to standard deviation. Okay. So when you multiply a single number towards a standard deviation, you multiply by that single number. If you're adding a single number to your data set, the standard deviation does not change. What happens if you have Aaron and Pete and they both have wiggle? They both are wiggling. What's going to happen? All right, now there's a whole weird, complicated formula. I'm not going to spend a half an hour in teaching you it, but it's basically like Pythagoras' theorem. Okay? Basically what you're going to do is you're going to take the standard deviation of one person, square it, add it with the standard deviation of the other person, and square it. And that will equal the total standard deviations squared. Okay? So think of it like that. It's almost like Pythagoras' theorem, right? A squared plus B squared equals C squared kind of thing, right? Okay, so remember, standard deviation squared, they do call variance. So this is the only time that I've ever really used variance, but usually we always say standard deviation squared. So that's okay. All right? So, you can never add variances only if the two random variables are independent. Yep. So you can only combine variances or standard deviations if they're independent. So let's see what's going on here now. Oh, yeah, yes, yeah. What happens if we want to subtract? Okay. What if we want to subtract two variables? Well, guess what you're going to do to the mean, guys? If you want to subtract, the means will stay the same. Or, sorry, you're just going to subtract the means. Like I said, I'm a little out of it right now. I just feel like closing my eyes. So you're just going to subtract the means. Standard deviations, though. Notice, what happens when you want to subtract or you want to find the difference between two standard deviations? What do we do still? We still add, don't we? I guess the best way that I explain it is whenever you got things that are wiggling, right? Think of standard deviation as how much you wiggle. Wiggle, 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 wiggle. And you got two things that wiggle. Whenever you combine them, the wiggles just get bigger, right? So it doesn't matter if you're subtracting them or you're adding them. The wiggles are getting combined, and wiggle on wiggle always gets bigger. There's got to be a better phrase than that now. I don't know. Can't think of anything that rhymes with wiggle. But, okay, so you're always going to add standard deviations. Okay? Doesn't matter if you're adding or subtracting. You will square them both and then add them together. All right. So, here's a situation. Okay, and you'll see things like this. In fact, there's an AP Stats question I need to pull out about egg carton that was a couple years ago. They did. And the same thing. Average calorie of an orange is 85 calories with a standard deviation of 3.2. Cuties are half the calories. What would be the mean and standard deviation of them? All right. So, first of all, we are talking that cuties are half the size, right? So it says to divide these by 1/2. So if the calories of an orange is 85, then a cutie is going to be half that. So the cutie, I'm going to say the mean of a cutie, we'll go mean of a cutie, is 42.5, right? Okay, now here's where it gets a little, we just got to think for a second. Now standard deviation is always a little bit different, but all right, what happens if I want to divide a standard deviation by 2? Well, whenever I divide, it's just like multiplying, same rule, and I divide, all right? The deviation will change. It's going to be half that, so it's going to be 1.6. Okay, so what will be the mean and standard deviation of the cuties? There we go. They're half of it, right? So the mean cutie calorie would be 42.5, and it would deviate by about 1.6, so half the deviation. Now let's keep moving on. The average calorie of an orange is 85 calories with a standard deviation of 3.2. If you had a box of 12 oranges, what would be the average cal and standard deviation of the box? Ooh. Now, I want you to think about this, because this orange has an average calorie of 85, but it can deviate by 3.2, right? It can go bigger or smaller, right? So this deviates. It's not going to be necessarily 85. This guy also has a mean of 85 calories, but it can deviate, right? Maybe both of these are on the smaller end. They could be, right? Anyways, each one of these is a different variable. We do not know what each one is, right? Each one could be different. They're not all going to be the same. So this is what we're talking about today. Each orange is its own variable, okay? Because they can vary at different amounts. So what will be the average cal? So the mean of the box, we'll say mean of B, is going to be, well, it's 85, but I want 85 plus 85, right? Plus 85. And you should get smart here and say, well, there's 12, right? It's a box of 12 oranges. So you could just go 85 times 12. All right, let's do that math quick, sorry. All right, 85 times 12. So I got a mean for the whole box, the calories. If you ate the whole box, you would average about 1,020 calories. All right, that's on average. What about standard deviation, though? Now remember, like I said, each orange can deviate. So this orange has wiggle, this orange has wiggle. What happens when I combine multiple wiggles? It gets bigger, right? So this is where we get that formula, all right? The standard deviation of the box, we're going to say squared, is the standard deviation of the first orange, which would be 3.2 squared, plus the standard deviation of the second orange squared, and so on and so forth. You guys get the feeling? You get what I'm smelling here? Okay, so it's really going to be 3.2 squared, and how many of those do I have added together? 12 of them. So I'm going to multiply that whole thing times 12. So I'm going to go 3.2 squared times 12. There's 12 of these. That is 122.88. But remember, we're missing one step. This is standard deviation squared. So 122.58 is standard deviation of the whole box squared. So I need to square root it. So let's square root it. And the deviation of the whole box deviates by about 11.09 calories. Make sense? Cool. All right. If I had a box of 12 cuties, what would be the average calories and standard deviation? All right, so it's going to be basically the same thing. Now, I'm running a little out of time. But remember, the mean of the box is going to be, well, the cuties was what, 42.5, right? And I had 12 of them. So I'm going to say add it, or you could just say I'm going to multiply it by 12. Okay, that's going to be the mean, all right? 42.5 times 12. It's 510. Now, you might say, oh, that was really easy, because that's exactly half of the box of that. All right, let's see. Do you think it's going to be half standard deviation? Well, you're going to have to figure this out. All right, I'm going to pause this in just a second, and we'll reveal the answer. So you might want to pause it as well and get your guys' answer. All right, so what I did was I took the standard deviation of the cuties, which was half. I squared it. And then I said, all right, well, I've got 12 of those. They're all being added together. That gave me this. But remember, this is the variance. So I'm going to square root it to find me the standard deviation. And I get a standard deviation of a whole box of cuties is 5.54. And that is half of the orange as well. So you can kind of see how that works. All right, I've got another couple situations. Try this with the bank. And we are going to move on with these next episode. Bye.